Good afternoon, esteemed panel members and all the members present here. So, quality is a continuous process, and at L&T we have it in our blood. We are extremely happy and honored to present you one such case study by LQC Swatchalith on high cycle time for frame bracket welding in ship structures. So, as we are following the LQC methodology, which is 6-step methodology, this is the flow and content of our presentation. Talking about L&T, it is India's largest construction and engineering conglomerate with a market capital of 5 lakh crores. We are in varied business like heavy civil, hydrocarbon and precision engineering system. We are from precision engineering and systems, which is in 4 business verticals like naval, land systems, advanced engineering and emerging segments. We are from the marine and naval platforms. We belong to Vizag site, which is undertaking construction of advanced critical vessels, and we are proud to tell that we contribute to that Atmanirbhar unit. Talking to our team, our coordinator is Ms. J. Pratibha and our facilitator is Mr. B. Kiran Kumar. Namaste panel members, I am Mohammed, the team leader.
Namaste panel, I am Pawan Kumar from Supply Chain Management.
Namaste panel, I am Baj from Welding Department.
Namaste panel, I am Lakshmi from Planning.
Namaste panel, I am Sagar from Production Department.
We have started our journey on 10 Jan and completed by 16th August. We have undertaken around 17 meetings.
We are team from Swatchalith. Let us understand hull fabrication in shipbuilding. In ship construction, the hull fabrication divided into structure, piping, electrical. So let us deep dive in the hull fabrication. 25% of hull fabrication involves 60 km of running meter. That is process-wise. If you see SMUW, GMUW, GTAW.
Ship hull fabrication involves various kinds of materials including low alloy steel, carbon steel, stainless steel, out of which 80% of the material is low alloy steel, that is consists of DMR grades.
As we already know that 60 km of running meter required in structural welding, which includes decks, frames and bulkheads. In generally naval ships require construction of double bottom.
What is double bottom, Lakshmi?
It has inner hull and outer hull.
Why it is required?
It is required to maintain the stability and position of the boat. Constructing a panel with a material DMR 249A, which gives a strength and a need for the structural requirement by manufacturing plating, frame brackets, longitudinals.
What is DMR 249 APA?
DMR 249 grade is a type of quench and temper steel which consists of multiple heat treatment cycles, and after heat treatment cycles it gives the ultimate tensile strength of 510 megapascals.
Okay.
So, a journey of 1000 miles starts with a single step. We started with selection of the problem using tools like brainstorming and flow diagram. So, let us first understand that how our outer hull panel is manufactured.
How process starts with the plate cutting.
Then it will go to the plates of assembly where we will long see the outer panel.
And formation of the frame bracket. Construction of a frame bracket involves multiple structural components. For a boat, we need to fabricate 575 frame brackets. After formation of the frame bracket, we will go to the carcass formation and subsequent activities will be taken care.
While analyzing the process flow, it is clear that without welding of frame bracket, work cannot move forward. So, it is a bottleneck. We have to weld 575 frame brackets, which is very huge in number.
So, during fabrication of this 575 frame brackets, there would be a lot of challenge like size and complexity of structures.
Access and positioning.
We require high skilled workforce.
Health and safety.
And this all leads to reduction in production efficiency.
As you can see, a panel which required to manufacture a frame bracket, which requires high cycle time and flat position welding, which leads to distortion. Hence, we require a high skilled manpower.
So, it is clear that frame bracket welding is becoming a challenge. Hence, Steve, what is the problem we have selected for our IQC project?
High cycle time for welding of frame brackets.
So, let us target 50% cycle time reduction for frame bracket welding. So, well-defined problem is half solved. After selection of the problem, we move forward with definition of problem using Gantt chart and matrix diagram. We have used DMAC methodology and divided the problem into 6 steps, and we have given clear timelines for each step. So, when a frame bracket is welded, 4 types of seams are to be welded. The first 2 seams, which are of full penetration in nature, are around 3500 mm welding, and they require an additional requirement of radiographic testing, while the balance 2 seams are around 5500 mm welding, and DPT test, total 7,800 mm of welding is to be completed for fabricating one frame bracket.
So to tackle the problem, start by measuring it. Here we use two tools. One is 4W plus 1H and other one is matrix diagram. So what is frame bracket welding?
Frame bracket welding involves bulk bars, stiffeners and combings, and we have a dependency on high skill welders, and we face low FTR in non-destructive testing.
When the frame bracket will be welded?
It is the first component welded during the outer hull panel fabrication.
Where it is welded?
OH panel subassembly with loose items.
Who are involved?
Welder, grinder, production engineer and welding engineer.
Then how to be welded?
Currently, we are welding the frame bracket by manual process, and we need constant requirement of grinder also to do the weld visual and final weld visual cleaning.
For welding of one frame bracket with a total seam length of 7816 mm and welding time takes 480 minutes and total seam preparation time is 815 minutes. Welder efficiency is calculated as 20%, where in the 8 hours of shift, only 1.6 hours is arc time.
Oh my god, only 20% arc time in 8 hours of shift. Don't you think it is very less, Sagar?
Yes, but it is very less. 5 man days is consumed for welding and 7 man days is consumed for weld visual preparation, and estimated cost is 18,500 and total man days is 12.
So now we have measured the problem, we know where we stand. So let us analyze deeply the problem using tools like brainstorming and cause and effect diagram to arrive at the final root cause.
Team has undergone the brainstorming and find out the following causes, which are deposit rate, internal passing grinding, high skill, and etc.
These causes were further divided into 4 categories using fishbone diagrams in man, method, material, and machine. Further, for each category, we deep dive up to R2 level to find the real root cause. For example, in man, there is a resistance to learn new technology. Why there is resistance?
They are comfortable with the existing process, Mohammed.
Okay, why?
They have less concern, Mohammed.
What else could be the reason?
They have safety concerns, Mohammed.
What else?
They are making mistakes, Mohammed.
Similarly, we have done for machine and method where points like interpass grinding time were discussed, high setup time, and automation is not possible. Why automation is
There
not
is high
possible?
volume is Mohammed.
Okay, what else?
There is varying path for each seam.
Oh, I see. So, after a deep analysis of all the 4 categories and discussion with all the team members, we have arrived that the most significant root cause is. So, let us tackle this root cause.
After identifying the root cause, now it's time to find the optimum solution. So team has used the techniques like brainstorming and matrix diagram. So for that we have taken the help of Industry 5.0.
What is 5.0 industry?
Industry 5.0 is a combination of advanced technologies as well as with human intelligence.
What is the main goal? Is
The main goal of Industry 5.0 is human-machine collaboration.
there any key technologies?
Yes, the key technologies in Industry 5.0 is AR/VR, collaborative robots, and eco-friendly materials. Since our problem was based on automation, so we have took the help of adaptive cobots.
What is cobot?
Cobots are designed to work alongside with humans in a shared workspace.
Is there any safety features?
Yes, the cobots are built in with safety features.
What about flexibility and ease of use?
The cobots are very flexible to use and they are used for multiple purposes.
Then they are highly expensive, right?
No, the cobots are very less expensive when compared to industrial robots. As you can see, there are many applications where cobots are used.
But why is it not feasible to use robot?
Yes, very good question, Sagar. But for the same payload and same reach, the cobot is much lighter when compared to industrial robot.
What about program?
For robot, you need a highly specialized program. But cobot you can easily use.
What type of task can be performed?
The robot is used for repetitive tasks, but cobot you can use for multiple tasks. For our purpose, we have used the ABB cobot and Fronius PPS 500 type power source for welding purpose. We have used the advanced robot assistance systems technologies like touch sense and seam tracking. In touch sense, as you can see, it will take the initial 2 point and final 2 point, and based on that, it will automatically detect the seam and welding will happen. After touch sense, it will go for seam tracking. So in seam tracking, if the path is deviated, final path is deviated, it will automatically detect and welding will happen in the original path only.
Mohammed, for the effective implementation of cobot, we should know the weld joint, right?
Yes, that is very important factor to know the groove diagram. For the first 2 types of joints which are groove and require full penetration, these are the configurations which are to be followed. While the last 2 joints are fillet joints without any groove preparation, and this is what to be followed.
But then weld sequence and bead sequence will be difficult.
Weld sequence and bead sequence is very easy when compared to cobot because cobot you can operate with hands, so it is very easy to do weld sequence.
So after starting the welding, obviously we landed up in some challenges like frequent start and stop.
By doing the payload, we rectify the problem.
How you address the identical?
By adjusting welding performance parameters, we rectify.
What about radiograph defects?
Of course, we encountered the radiographic defects with proper root cause analysis and settings. We encountered them.
After encountering all the challenges, these are the welding parameters which we have used for full penetration and partial penetration joints.
After finalization of parameters, we successfully completed the welding. But the task is not complete until we clear our check sheet, which is a quality check sheet. Following tests were carried out.
So after welding with the cobalt, we achieved 100% visual test. So visual test is
Accepted.
After visual test, we have done DPT and no defects are identified in DPT and DPT was also
Accepted.
After DPT, we performed RT with no defect and accepted.
Accepted.
With minimum distortions and no corrections required, final dimension checks are satisfactory and it is
Accepted. Hence, we got our quality stamp of high quality. Now, we have done our reached a good quality. But what about timings? Did we achieve our targets?
Yes, Mohan, we achieved. With the implementation of cobalt, total time welding time decreased to 424 minutes and total seam represent time is decreased to almost 50%. And deposition efficiency is increased to 30%. And arc efficiency of welder is 45%, which is 2.5 times more. And estimated cost is 7,600. And man is decreased to 5.
So, the maintenance earlier were taken 12. Now it is decreased to 5. So, team, how much timeline reduction have we achieved?
58% reduction.
Great team, we targeted for 50 and we have achieved 58% reduction. So, team, before how we used to weld the frame brackets?
Process.
And now, after implementation of cobalt, how are we welding the frame brackets?
Automated cobalt CFW.
So coming to the conclusion, we achieved an excellent field finish with the welding of the cobalt. Cobalt is user-friendly programming with improved safety standards.
Yes, after implementing a solution for a major problem, it is required to streamline the process. As we streamlined, we have prepared a SOP for cobalt welding and we undertook the awareness session for the workers and we are regularly monitoring KPIs.
After streamlining and the process, we did productivity analysis also to clearly define that cobalt GMW is helpful in various parameters like deposition rates till flexibility, and all the parameters cobalt GMW was found superior.
Mohammed, we can see the tangible benefits. What about the intangible benefits?
As such, there are some intangible benefits also. We have achieved high customer satisfaction, less strain on workers, and improved economics of welders.
So, panel members, this is our actual Gantt chart where we have achieved all the tasks in time except one measuring the progress, where we took some more time.
We have undertaken GMW process with continuous improvement. We have set a new benchmark in this year with the implementation of cobalt. And we are very proud to say that we are first in LND to implement cobalt.
So, let us deep dive into what business impact these improvements have created.
So 30% increase in deposition rate and 58% cycle time reduction.
2.2 lakhs of cost saving when compared to manual welding.
FTR increased 98%.
With zero safety incidents and ensured management of change like risk assessments.
So, after successful completion of our LQC project, we further want to go for different other problems like welding cycle time reduction of assembly joints and cycle time reduction of sub-assembly plating joints. Panel members, these are the references which we have followed. Dhanyawad.